with an equal sign, we can take out a 2, and we're left with 5x plus 2. The bottom, we can't do anything, so we write 5x minus 1. Then we can multiply, we just need to take that negative x plus 1 up top. And then we take a 7 out of the bottom, and we're left with 5x plus 2. Now the catch with division is we take NPVs for everything but the top. Everything but the top what? Left, right? Division, you state for all the NPVs. So we're going to have x can't equal 1/5 for the bottom left, and x can't equal negative 2/5 for the bottom right, and then x can't equal 1 for the top right. We'll do it for everything but the top left. Remember, division is the only one with that extra NPV. Now the only thing that can cross off is the 5x plus 2, so I'm left with 2 bracket negative x plus 1 over 7 bracket 5x minus 1. X can't equal 1/5, negative 2/5, and 1. Okay. Number 2, the top left, I can take out a 2y, and then left with y minus 2. The bottom, I can take out a 3y, and I'm left with y minus 3. Times the y plus 2, y minus 3 moved to the top, the numerator. The bottom, y squared minus 4 is y plus 2, y minus 2 is the difference of squares. So I can't cancel anything off until I state non-permissible values for everything but the top left. 3 doesn't get me an NPV, y by itself is 0, y minus 3 gets me 3, y plus 2 gets me negative 2, y minus 3 gets me 3, I've already stated it, y plus 2 gets me negative 2, and y minus 2 gets me 2. Then I can write it over one whole denominator. These cancel, these cancel, these cancel, these cancel, and my answer is just 2 over 3. Y can't equal 0, 3, plus or minus 2. So don't forget your non-permissible values with division, right? It has that extra non-permissible value you have to watch for. And often on the test or on the diploma, they ask a division in division.
You didn't take the 2y squared out.
Oh, poop.
Poop.
I just said poop on the podcast. Is 4a squared minus 1? 4a squared minus 16. I'm going to give you a hint to this left one here. Before you do a difference of squares, you should take out a ECF, then do a difference of squares, or you make your life not as pretty. Divided by 2a minus 1 over 2 minus a. Oh,
I want to do it.
Calm down. Then we have 4x plus 12 over 3x plus 12 over 3x squared plus 9 over x plus 4 squared. Now, before we freak out about that one, what's the catch? What does a double stack number do? What operation is it?
Division.
Division. Just write it out sideways. So you're going to go 4x plus 12 over 3x plus 12. Divide by symbol this. So the top left of this one is 2a plus 1, 2a minus 1. The bottom, I told you to take a 4 out first, then you were left with a squared minus 4. So you're going to get 4a plus 2a minus 2. And then times, now we get 2 minus a, but I need a minus 2. So I'm going to take a negative 1 out, and it switches my sign. So I'm going to get a minus 2. So remember, if they're the same wrong sign, take a negative 1 out to match. Because this one's positive 2 minus a, this one's positive a minus 2. So same but wrong. Wrong signs. And then I have 2a minus 1. I have to state NPVs first. Right? Stop.
Oh, it's actually not him, you're right.
Is it clear? Stop. I figured out who it was.
Oh, it is too.
It is.
What?
Cover that thing up. She doesn't even know she's blind as well. That's like a good tactic. No one would have suspected. Okay, so a can't equal plus or minus 2. This one's still 2, and this one's a half. Then draw straight across. A minus 2 is canceled. 2a plus 1 does not cancel. Darn it. Let's go back. 2a minus 1 is canceled. A minus 2 is canceled. I already did that. And then you get negative 1, 2a plus 1 in brackets, over 4a plus 2. And then a can't equal plus or minus 2 and a half. Okay, and then here we have 4x plus 12 over 3x plus 12 divided by 3x squared plus 9 over x plus 4, that's the square in these. Now, I made this one not work out as nice as it's supposed to because you guys freak out when something with not lots cancels off, and sometimes lots cancels off. That's just how it works. So this one we take a 4 out, we're left with x plus 3. This one we take a 3 out, we're left with x plus 3 times x plus 4, x plus 4, x plus 4 over, I see you trying to blind me, 3x squared plus 3. I don't know who's trying to murder me with light, but stop it. Okay. X can't equal negative 4. And these are negative 4, negative 4. What's x squared plus 3 is the difference of squares. What does it get for an FDB? X squared plus 3. Nothing. Difference of squares gets you no MPB, so that's not going to 9 minus 4. These cancel, and then that's it. So you're left with 4x plus 3x plus 4 over 9 x squared plus 3. X can equal negative 4. Okay, I'm going to give you 2 more. 5. I'm going to give you 3y minus 1 over 3y minus 2 minus 3y minus 2 over 3y plus 1. When you add and subtract, what must you get?
It's
Common denominators. These 3y minus 2's do not cancel off. This is a multiplication. Then 6 is going to be 3 over 4x plus 2 minus 1 over 6x plus 3. Please pay attention. What's the very first thing you should do with your denominators? Check if you can. Make them the same. Check if you can take out a GCF or a difference of squares, right? 3y minus 2, 3y 1 plus 1. Can I do anything to those? No, so I multiply by each other. This one, however, looking, 4y plus 2, 6y plus 3. 4y plus 2, I can take out a 2, and I'll be left with 2x plus 1. 6x plus 3, I can take out a 3, and I'm left with 2x plus 1. They'll match. The only thing that won't match is the 6, or the 3 and the 2. So that's all you have to multiply each other by is the 3 and the 2, as long as you spot GCF. So try it out. Quiet, please. So we have to multiply this one by 3y plus 1 to make it match. This one by 3y minus 2. So we multiply the tops, not the bottoms. Remember, when we multiply 2 binomials, we're going to get 4 terms, not 2. In this case, some cancel stuff, nice, but anyways. 3y times 3y is 9y squared. 3y times 1 is 3y. Negative 1 times 3y is negative 3y. And negative 1 times 1 is negative 1. All over, not distributing my denominators. Minus 3y minus 2, 3y plus 1. And then I FOIL, so I get 3y is 9y squared. 3y minus 2 is negative 6y. Negative 2 times 3y is negative 6y. And then negative 2 times negative 2 is positive 4. Then we write it all over one denominator, 3y minus 2, 3y plus 1. And we get 9y squared, these cancel, minus 1. And then we have to remember to subtract everything behind the subtraction sign. So minus 9y squared plus 6y minus 4. Then we collect like terms. So we get The 9y's canceling. 12y. Guys, quiet, because they can hear everything you're saying. 12y minus 5 over 3y minus 2, 3y plus 1. And then we get y can't equal 2/3 and negative 1/3. For 2, I gave you a hint and told you that you need to always check for adding and subtracting, and for solving, you need to check if you can make your common denominators with your denominator. So I can take a 2 out of this one. GCF, the difference of squares, is what we have to check for first. I get 2x plus 1. And 3, this one I can take out 3, and I get 2x plus 1. And if I spot that, this question is actually quite easy. If I don't spot that, your life is a lot more complicated. So I'm going to multiply this one by 3, and 3, and 2, and 2. So I'm going to get 9 over, and then these are monomials, set them together, 6, 2x plus 1, minus 2 over 6, 2x plus 1. And so I get 9 minus 2, which is 7 over 6, bracket 2x plus 1. So if you spot the GCF, this question is actually quite easy. If you don't, it's not. Yeah, sit down, you're going to open up your Sept your notes. Naturals, wholes, mixtures, rationals, reals. We dealt with prime numbers. This one is not a prime number. We dealt with composite numbers. We dealt with opening our notes up to where we're supposed to be at. Oh, wait, we didn't. That's now. We dealt with universal set. The universal set is the big set where you can take information from, correct? So if your universal set is 1 to 9, and I ask you for odd numbers, you can only list the ones, a subset being the odd numbers, you can only list the odd numbers that are from 1 to 9, right? Or prime numbers from 1 to 9. So the universal set is represented by that proportional shape. Yeah.
So when you said list the universal set, it's been like 1 and 18 of the prime numbers, and then you said 1, 3, 4, 2, 17. And you're saying universal means 1 to 9.
That one, the
3,
universal.
17.
Because that my universal set that I just made up was 1 to 9.
Oh, so they changed. Like,
Yes.
It's not all 1 to 9.
Nope, every single question.
Oh.
Yeah. So it could be whole numbers less than 10, one of them. It could be whole numbers less than 19,
So
another
it's just saying like that is basically saying the universal set.
of that question. Yeah. So here we have a subset. A subset is a set that contains some or all or possibly none of the elements. So a subset that contains some, possibly all or none. And it'll make sense when we go over it. Yeah. From a previously defined set. So, all sets we deal with in a problem must be subsets of the universal set. So what does that mean? That means if I ask you for a subset of something from the universal set, it has to contain the numbers from the universal set. So let's look at this. I'm going to give you a pretend thing. I'm going to say U is the universal set. It's from the previous page, but I'm going to make it my own new one. So I'm going to say U is 1, 2, 3, 4, 5, 6, 7. Our universal set are the natural numbers less than or equal to 7, I could say, or the natural numbers less than 8. Then, if I talk about E, we'll say E are the even numbers. Well, the universal set is 1 to 7. E is a subset of the universal set. So any set that we make out of the universal set are also called subsets. So E would be 2, 4, 6, or 8. Is everything in E in U? Is everything in E in the universal set? Yeah. So I can say that E is a subset. It's just a sideways U. And if you forget what the symbol is, it's on your formula sheet. It's a sideways U. E is a subset of the universal set. Because everything in E is in U. We agree?
Yeah, that's what I was going to say. I thought there was an 8 in E.
Because I wrote it illegally. Because I thought we were 1 to 9, because that's what I had made, but then I rechanged my universal set to something totally different. So it's contained in it. Now, can I say the universal set is a subset of E? Is everything in the universal set in E? Nope. 1 isn't in E, 3 isn't in E, 5 isn't in E, 7 isn't in E. So in order for something to be a subset, it has to contain everything in the previous set. So for example, Amelia is a subset of the people in this class, correct? But Frank, who I don't even know who that is, I just made the name up, is not in this class. So they're not a subset of the people in this class, right? Now, Amelia is a subset of the people in this class. Or are the people in this class a subset of Amelia? No. She's in the class is not technically living in Amelia, which is super creepy. So a subset means you contain the whole thing inside. So you can make a Venn diagram to check subsets. If you made a Venn diagram to check subsets, you could make sure that it forms an egg shape. The subset should be the yolk and the egg. So, for example, if I drew E would be 2, 4, and 6, correct? And then if I drew the universal set outside of it, it would have 1, 3, 5, and 7. And that would represent everything, wouldn't it? So in order for something to be a subset of something, it has to be the yolk and the egg. Now, can the universal set be a subset of itself? Is everything in the universal set in the universal set? Yeah. It would just be an egg without a yolk. But it would still be the same thing, right? You could draw the yolk technically. It would have 1, 3, 5, 7, I don't know why I'm going this route, 2, 4, and 6. And then if you drew the universal set around it, it would just be empty. So it would still include it, right? Because the universal set is a subset of itself. Everything is a subset of itself. So if I went E is a subset of E. Everything is a subset of itself. Now, if even one thing isn't in there, it won't work. So let's say I give you L. And let's say L is the numbers 1, 2, and 4. Is L a subset of E? Is everything in L in E? No. What's in L? It's not in E. 1. So L is not a subset of E. And how do I know that? I can go L is 1, 2, 4. If I drew E, I'd have to go like this. Wouldn't I? I'd have to kick that 1 outside of it. So is that an egg with a yolk in it? No. There's an outside piece that isn't included in it. So it would not be a subset. So in order for something to be a subset, everything has to be in it. Now they say or nothing has to be in it. This is the stupid part, but it's true. This is called the empty set. So I'm going to call it A. If I go like this, 0 with a slash through it, it's the empty set. And it's right here. It has 0 with a slash through it, empty set. So there's actually nothing in A. Can I say that A is a subset of E? Is technically everything in A in E? Yeah, A is empty. So everything in it is in it. So actually the empty set is a subset of everything. Because it's empty. This 0 with a slash, it's not a 0. It means empty set. So 0 with a slash means there's absolutely nothing in that set. So it contains nothing. It's empty.
What if it was even versus odd, it's like they're subsets of each other? Like they're subsets of the universal set, but they're not.
So you could go evens are a subset of the universal set. You could say odds are a subset of the universal set. Then you could say that E is not a subset of odds.
Okay. But there's no like specific that.
No. And we deal with like opposites. They're called complements, which we're going to get to. So here's the empty. Whoa. Okay, the empty set. I don't know where I moved all these words. They're somewhere. So the empty set is a set that contains no elements, which is what we showed with the slash thing, right? So if you were to show the set of elements that set's empty, you put a 0 slash through it. So for example, the set of all numbers in set E is empty. So if they made set E odd numbers, let's say, empty because there are no odd numbers in set E. So say I gave you set E, and it was like this. 1, 2, what am I doing? 2, 4, 6, let's say it's that. And that was the universal set, let's pretend, right? And then I said, okay, so I'm making this be the universal set, which is E. then the odds would be empty because I'd have none to choose from, right? So empty set comes from when you ask for something, but the universal set doesn't actually contain any of it. It'll also be when we combine, we'll put two of them together and we'll say how many are in this one and in this one. And in this set and in this set, they have nothing in common. So like you were saying, odds and evens. We're going to learn about ands. So if we went odds and even, this symbol means and, that would give us the empty set because there's nothing odd and even. That's what we're going to talk about after. So complement of set, this is what we were talking about before. I know you asked this, how can we write that? So what I could do is I could say E is even, and then I could say E complement, which is just that. Is odd. Can I say P is prime, and then P slash or P prime, technically? There's a little thing called prime, but we can do prime. Is not prime? Yes. I can say this. I can say P is not prime, the not prime numbers. But can I say that that's complement? I mean, composite? Can I say P prime is composite? No, because our composites and prime numbers are opposite of each other. No, they're very, very close, but there's the number one that doesn't fit in either of them. Correct? So I can say P equals prime, and then P prime is not prime, whatever's not prime, which would include all the composites plus 1. Right? So I can't say that that's composite. All right, let's look down here. So we have consider the following two sets. Natural numbers less than 20. Natural numbers start at what? 1. Less than 20, we're going to stop at what? 19, that are divisible by 3. And then natural numbers less than 20 that are divisible by 5. Now, explain why the set of natural numbers less than 20 is a suitable universal set. Why are the natural numbers less than 20 a suitable universal set for A and B? Because it's stated in bold, is it not? For this one, it says I can only use natural numbers less than 20. This one says I can only use natural numbers less than 20. So it's because it's stated in bold. So it's the only numbers I can use, right? So let's list the universal set then. So natural numbers less than 20, I have 1, 2, 3. Don't do dot, dot, dots, because there could be anything between dot, dot, dots, right? You could have decimals falling in between. Right? You'd be like, but that's a weird assumption since the rest are whole. The rest are natural. You have to list them all. You can't just go dot, 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 19. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Now, the people who actually list them all make less mistakes. First off, you're right to list them all, and second off, you make less mistakes if you don't miss any numbers. Now, for B, it says list the elements in the following set. So I have to list what's in A. A are the ones that are divisible by 3. So what numbers are divisible by 3 in that universal set? 3. Divisible by 3 means you divide it by 3 and you get a whole number, right? Or integer. 3, 6, 9, 12, 15, and 18. B are the ones that are divisible by 5. So which of those in the universal set are divisible by 5? 5, 10, 15. What does A prime mean? What does this A with the prime symbol mean? Yeah, so it's a complement of A, so it's what's not in A. That's what that little prime symbol means. It means what's not in A. So what's not in A? Well, I have A listed. Honestly, doing the complement is so much easier if you have the actual A. Because then you just list everything that's not there. So I'm going to go 1, 2, 4, 5, 7, 8, 10, 11, 13, 14, 16, 17, 19. What's the description of the complement of B in words? B complement in words is like that. So it's the natural numbers less than 20 yes, less than 20 that are not divisible by 5. So here it states that set C are the natural numbers less than 20, once again, still the universal set, that are multiples of 6. So let's state what falls in C. Multiples of 6, so we get 6, 12, 18, because multiple starts at that number, goes up by that number, right? I want you to tell me whether these are true or false. Is C a subset of A? Subset means, another way you can say instead of C is subset of A. Everything in C would be in A. You'd make a yoke. Is everything in C and A? So we look at C. C has 6, 12, and 18. Is that in A? Let's look. What's A? 6, 12, and 18. So this is true. What about the reverse, though? Is A a subset of C? Is everything in A and C? A has 3, 6, 9, 12, 15. C has 6, 12, 18. Is everything in A and C? No, it's not a subset. The next one says C is not a subset of B. So we go look at C. C has 6, 12, and 18. Is it found in B? B is 5, 10, and 15. Is everything in C in B? No, actually not everything is. Actually none of it is. So it's true. Now I need the complement of A as a subset of the complement of C. Now people will find this hard if they just don't take the time to write out the complement of C. If you write out the complement of C, you can actually check, right? If not, you're going like, okay, I think it's 1, 2, 3, 4, 5, and then 7, 8, 9, 10, 11, and you're checking it that way. So I always go and don't waste my time, and I literally write it out. So I'm going to get 1, 2, 3, 4, 5, 7, 8, 9, 10, 11, 13, 14, 15, 16, 17, and 19. So in order for this to be true, everything in not A has to be in C. So I'm going to go to not A and check if it's in C, not C, right? That's how you do it. See what's in not A and check and see if it's in not C. So 1 is in not A, it's also in not C. 2 is in not A, it's also in not C. 4 is in not A, it's also in not C. 5 is also in not C. 7 is in not A, not C. 8, 8, 10, 10, 11, 11, 13, 13, 14, 14, 16, 16, 17, 17, 19, 19. So it's good. Because everything in not C is in not A. However, is not C a subset of not A? No, because not C actually is more than not A, right? So this is not.
A, B is not A, is a subset of not C. Oh, never mind.
But are all those sets a subset of the universal set? Yes, because that's where they came from, right? Okay, this is your homework assignment. I'm going to, you're going to start working on it. I'm not going to until the end of class. You just have to start working on it. For the next little while. I'm handing this out to you. It's not in your textbook. It's a handout. So we're not doing these. We're going to start at 3.